Hi, it's time for another math easy solution. Today we'll discuss some more derivative examples using the chain rule and basically look at part 3 of this video series. First of all, I'm just going to recap on the chain rule. You can see more on the chain rule and the proof in the video links below. Basically, if you have a function within a function like y equals f of g of x, then the derivative dy over dx is just going to equal to the derivative of the outer function, or f, in terms of g, the inner function, and then multiplied by the derivative of the inner function in terms of x, or whatever it was inside the g of x. Or in other words, y prime is equal to f prime times g prime. So now let's look at these two examples right here. Let's go over example 1 first, which states g of t equals to t minus 2 all divided by 2t plus 1 and all to the power of 9 right here. So in this one we're going to actually apply basically, if we write example 1 right here, we'll have to write the power rule, quotient rule, and chain rule all in one. I'll show you what I mean by that. Yeah, basically if I write it down right here, so this inner function could be considered as basically the inner function g of x, etc. Looks like that, and the outer function could be our f of x or f of g. So basically first we'd use a power rule. You can see video link below on the proof of that to get the derivative. So we'll get g prime of t is equal to, we'll bring down the 9, and then we just basically have now t2 minus t, so this is the entire one, 2t plus 1, then we subtract 1 over there. Now we have to take a derivative of this inside function, and that's just going to be using our quotient rule. I just want to write down quotient rule right now. If you have, let's say, y equals to f divided by g, see proof of this in the video link below, then the derivative will just equal to f prime times g minus f times g prime, all divided by g squared. So in this case our g is going to be 2t plus 1, and our f is going to be the top t minus 2 right now. So the derivative of the top one is going to be, well, 1, derivative of t is 1, derivative of negative 2 is 0, so we'll have 1 multiplied by g, which is 2t plus 1, and then subtract this by we'll write down f t minus 2 times this by the derivative of the bottom, 2t plus 1, that's just going to be 2. And then this is all divided by, basically, yeah, this is all divided by 2t plus 1 squared. So 2t plus 1 squared right now. So using the chain rule, we have to find the derivative inside, and we just use the quotient rule. So this is what we get, and we can simplify this a bit further. So we write down equals, or g prime of t is equal to, simplify this, we'll have a 9 times it by t minus 2, 2t plus 1. If you're in an exam, you could probably just leave it like that. You'll get full marks unless they ask to simplify. So this one we're going to have 2t plus 1, subtract this by minus 2t, multiply that in, 2t, and then multiply negative 2 by 2, that's negative 4, times by negative 1, so that's plus 4, and then this all divided by 2t plus 1 squared right here. And simplify this further, 9, we'll just put that down here, then multiplied by this, simplify this, the 2t's cancel, the 1 plus 4, that's 5, so we get this, 2t plus 1 squared. Now this is the same denominator, 2t plus 1, so we could separate this, multiply by the 9 by 5, this can be 45, t minus 2 to the power of 8, all divided by 2t plus 1 to the power of 10 right now, because there's a 2 right there. So then that's, yeah, basically this is our final answer simplified. Okay, so now let's look at the second example, which is just y equals 2x plus 1 to the power of 5 multiplied by x cubed minus x plus 1 to the power of, all to the power of 4 right here. So this one we'll use the product rule actually to solve that one. Yeah, so I basically wrote that down right here. So now in this case there's going to be, well, there's two functions that have functions inside them. So this one right here has a function within a function. The outer one could be this power of 5, and the inner one's 2x plus 1, and same with this one right here. So we'll have an inner function here within this outer 4. So we could apply the power rule. If you realize my power rule, basically recap on that. If you have y equals f times g, then using power rule, you see proof of this in the video link below. This just equals to f prime times g plus f times g prime right here. So that's what we would have to do first, and then we'll in this case both of these will have chain rule derivatives inside. So we write that down, y primes equal to, look at the first one, derivative of this one using power rule, bring that down, 5, 2x plus 1, make it a 4, now we have applied chain rule, so multiply the inner one, and the derivative, that's just going to be 2. So times it by 2, and now we multiply by whatever g was, which is this, so x3 minus x plus 1 all to the power of 4. And now we add, I don't have enough space, so I'll add it down here. So now we add, we just write f now, which is 2x plus 1 to the power of 5 plus, multiply now the derivative of this one. So using power rule, bring the 4 down, x3 minus x plus 1 all to the power of 3, so we subtract 1. Now using chain rule, do the derivative of the inside. That's going to be, well, using power rule of this is 3x squared, put a bracket, minus 1, and the derivative of 1 is 0. So we have this one right here. So we could stop here, that's our answer. We could simplify it further just to get a better idea of it, and I'll do that right now, basically. But first, you should actually recognize that you could factor out similar stuff right here. Because in this case, we have a 2x plus 1 to the power of 4. This is to the power of 5, so we could take out a 2x plus 1 to the power of 4. So we'll go y primes equal 2. So we'll factor this one out first. 2x plus 1 to the power of 4. And there's also a 2 in both of these additions. So there's a 2 here. This is 4. Is just 2 times 2. So we'll put a 2 out. I'll show you what I mean in a bit. And now we also have this x cubed minus x plus 1 to the power of 4. But this one's to the power of 3. So then the 3 is contained in both these additions. So we could take out this one right out. So we'll have x cubed minus x plus 1 to the power of 3. So then if we take these out from both, we'll get inside this one we'll have a 5. So this one's all gone. We're left with now 5x cubed minus x plus 1. And then this one will have a 2 now because we took a 2 out. So plus, and we'll also be left with 2x plus 1 power of 4. 2x plus 1, so I mean we took out a cubed of it, so we just have 2x plus 1 there. So we have to multiply this by 2, and also multiplied by don't have enough room, so I'll just put it down here actually, then multiply by this one here, that's by itself, 3x squared minus 1. So we could do this one here. Now if we simplify this part further, we get basically y primes equal to, yeah, basically we get this part multiplied by now this one, multiply the 5's inside, so 5x cubed minus 5x, just a lot of algebra right here, plus 5, yeah, right here 5, and now we plus, well, multiply this inside, so 2x is going to be 4x, and then multiplied 4x by this right here, 3x squared, so we'll get 4 times 3 is 12. Let's do this all in one step. Times it by x cubed. And then now we have, so now we multiply by basically the same thing. 2 times 2 of x, that's 4x, times by this one, negative 1. So we'll get negative 4x. So again, that's what I kind of did. Now we do the same thing, but with the 1. So 2 times 2. Times by 3x squared is just going to be plus 6x squared. And then now we have 2 times 1 times negative 1. That is just negative 2. Yeah, so now if we simplify this even further, we get, I just wrote this down quickly. So now we have like terms right here, 5x cubed plus 12x cubed, that's 17x cubed, minus now, there's a like terms right here, this is a 6x squared, so plus 6x squared by itself. Go to the x's, that's negative 5 and negative 4, that's negative 9x. And now we have 4 plus 5 minus 2, that's plus 3 right here. So this is our final answer. Yeah, and here I've graphed the two the functions, the derivative and the original function using Google Graphing Calculator, just to get an idea of it, to see if we have our answer is reasonable. So as you can see from the red, which is the derivative, so this is y prime. When it's really, really high, our y, this is y right here, this is increasing. So as this is increasing sharply, this derivative is really, really high, as it should. And then as it levels off, our derivative is 0 right here. As even here at this point, it's level off, we have derivative of 0. So y prime is equal to 0. So as it should be. And as you can see in basically again when it's level off, it's another 0. And at this point right here where it's increasing slowly, right here it's slowly, and then all of a sudden it goes really high up. That's why it's increasing really high up there. And at this point right here where basically this is leveling off, there's actually an inflection point right here where it's going up from going concave up to concave down. And I think somewhere here as well there's a similar one right here. It's concave up and all of a sudden concave down, but it's really minimal, and it's going back up. Well, so basically this proves that our answer is reasonable, and it's probably right. Well, anyways, that's all for today. If you learned from this from these examples on how to use chain rule, quotient rule, product rule, etc. And like always, you can download these exact notes in the Dropbox link below. And thanks for watching, and stay tuned for another Math Easy solution.